differentials, one of the big things that we need to figure out is what we would call the general solution. All right, so we are solving differentials. What we'll want to do is find the general solution. Okay? So basically what we're saying is you're given a derivative, calculate the original function. Okay? So the difference between what you've seen with integrals and what you have in front of you, can you see it? Yeah, there's x's and y's on the same side. So, fortunately, we don't have to do anything implicitly. Okay. We are going to do what's called a separation of variables. Okay. So we would have all the x's on one side, and we would have all the y's on one side. We're separating those variables. So when we integrate, everything's nice and clean. Okay? Me too. You all right with that? All right, so if I look at number 1, how can I separate my variables? Yeah, multiply by y, correct?
Y.
Yes, in effect, you multiply by dx now. So what you end up with is you're separated. No. You have to actually solve for the equation. How do I get rid of derivatives? Yeah, anti-derivatives. Right. So now look at that, you have an integral of y dy. So what's the integral of y? Do I need to put plus c here? Notice how if you put it on both sides, guess what, they cancel out, right?
Yep.
It kind of gets rid of it. So what you don't want to do is, in the standard, we just put it on one side. Okay? There are reasons for that, but just put the plus c on the right, you're good to go. Okay?
So, what is the matrix of x next? So the negative with this direction or not? How would it be? Okay.
Now you need to solve for y equals. So multiply by 2, right? Do I need to put 2c? If I'm being mathematically proper, I should put 2c, but it doesn't matter. Because it's still just some unknown number. And then square root it. Don't forget your positive or negative, you get dinged for that. Okay, there's your general solution. you asked me if it was difficult. What do you think?
It's not too difficult.
I mean, it can get really nasty.
Yeah, like 3.
Three's actually not that bad.
Wait, no, you just use
How
the
about
actual
number
log,
2?
and it cancels it out.
Separate, can you separate the variables? Let me point this out. There are times when you cannot separate the variables. That is a case where you cannot separate the variables. You could, but look what it does for you. Can I factor a dx out of here and multiply it across? I cannot. Okay, so this is not, we would say is not separable. Okay. I mean, actually it is, and I'll show you how. Okay. Number 2, what do I need to do to separate? Yeah, so we get 2y and ey equals x squared sine x cubed dx. Right? Integrate. Substitution problem.
I hate you so
Oh,
much.
stop
I can't
it.
even see it. I just don't know when to do it, so I
Well,
just end up doing it.
okay, flat out, you look at this derivative, can you do it? But it's just,
I will try, is the problem. Whether I can do it.
Alright. Is there any integral that you know for a product rule? Or a chain rule? Right? So what's the derivative? Is there a 3 in here? Okay, so we have to 1/3 du is x squared, right? So the x squared is going to disappear. And I have the integral of sine u du. Now that can be I did. So if you look at an integral and think, there's no way to do that. Either A, it's a calculator-friendly problem, right? Or B, it's a U substitution
So
problem.
you can put that in a calculator and it'll solve it for you?
No, because it's indefinite. Remember, calculators have to have integral limits.
Yeah, no, but I'm just saying, like, if you actually put with integral limits.
Yeah, you can do it. So we get y squared equals negative 1/3 cosine x cubed, right? And then you can finish that, right? Kind of oddly. We'll get the job done. teach pre-calc we went over on Tuesday was properties of exponents. Right?
Well, yeah, you can just use the.
The exponents are subtracted. It means it's a division problem. Same base. If they're added, it means they're multiplied. Right? Okay, so use your properties of exponents knowledge. Now we can separate. Do you see it? Okay. You with me? Your head on, or you were staring I have no idea this actually exists until today.
Is it then why?
Let's stop. I didn't even think it was that funny, but it's
Oh, no.
the other way.
Yeah. Remember, you have to use natural log to edit your exponential heat.
Who
Who's
is
missing
it?
their blood drive appointment? Oh, come on, Sean, you love this class. Hello. Yep.
Rocking it at me again? Probably.
No, this is blood drive.
I think so, you're in chemistry.
Okay.
Thought I
You
did
okay with
too.
this one?
I'll take a together.
It's going faster.
Yes, no?
A lot of people aren't showing up.
It's the same procedure. Separate variables, integrate, solve for y. Okay? Separate, integrate, solve for y. Using some practice. Let's look at one
It's
more,
like a model or something.
and then we'll be done.
Oh, we're gonna have to use hard fields for these.
For these differentials.
Yeah.
It's not uncommon to see a pre-response with a differential equation where you do the slope field, and then in part B you solve for this solution. One more. This is not on your sheet, but I want to show it to you because it comes up quite a bit. This style. How do I separate? Divide by y, right? So what you end up with is 1 over y, dy equals x dx. That's interesting. You okay there? I assume. Now we can work it. What's the integral of 1 over y?
Natural law, I guess.
This is usually what will happen on an AP exam. I do not know why they choose that every time. Okay, that's conventional. We can't have negatives in natural log, send it mine. Could be a free response. These free response problems are usually worth 5 to 6 points.
For those 3 lines.
You have earned, so here, let me take you through a free response scoring. You have just earned 1 point for separating. You have earned 1 point for the correct anti-derivatives, and you earn a point just for putting plus C. Boom, baby. I love these problems for yourself. And there's usually a slope field worth 2 points. What's great.
So basically, that's almost a free, if you want to do it.
Okay. How do I get y equals here? Yeah, raise it to the power of e. Okay, the other points for these usually come from calculating the value of the constant and writing the actual equation.
How would you do with the actual value?
Do I know any information to be able to eliminate the absolute value?
You can square the other side, right?
I do not. I will show you tomorrow when you can and when you, how you deal with this. Okay? I will show you tomorrow how to deal with that. Okay. Here's a little caveat that you'll want to know. Is that legal? Property powers, right?
Does the top one say either that x squared or 2 plus 6?
Yeah, it does.
That's all raised?
Yep. It's all in the X bar. This is
Oh, so
illegal.
that would work.
Yeah?
Yeah. I think.
Yeah. Okay, and then the one thing that you usually see is they'll do this. Just common mathematical notation.
That's just so any other word.
E to the constant is the same as any constant. Okay, you get it.
I get it.
Mickey, you look really confused.
Okay, so that's CE, like C times E. Okay.
Yeah, see,
So basically what we've done is
X
taken
squared to that.
this piece and just made it some number of substitutes.
But why did
You
you
can't
write
see it? No.
Why?
But I understand the struggle when I was
This seems to be the case. I just need a second set of math because I can't find my cohorts.
Okay.
And I'm going to explain math to a one children listens to. But first that.
Are you good?
Yeah.
Okay, when we write the homework down, then we're done.
Why is it just C? Because E is just unconstant.
Well, yeah, it's just a number, right?
So
So e to the some power can also is just some number, so common notation is just to rewrite it more simply. Okay, the homework is actually from the book.
Oh.
Yeah, I know. They have terrible, our book's terrible at presenting this information, but the problems are actually good, so it's usually bad, but it's not very much.
will you write down the style of things you wrote down the other day?
Oh, yeah, if you want me to.
Spiraling through trees there, right?
Yeah?
Yeah.
Oh my gosh. Yeah.
Yeah, it's quite a bit of work, so I would consider that already good.
Thanks. This is the only thing
Well, I mean, it looks like a lot of work.
I can fix wrong T's, but I can't see anything.
Yeah. Spot. Back.
There you go.